In the last 10 years, we've seen the cloud change what's possible with social and mobile applications. Now, engineers and scientists get their turn to ask, what can I do with all this power?
Computational science and engineering is creating computer models of real-life physics.
Using simulation, advanced analytics, and high-performance computing to help simulate how real-world phenomena or products would react in the natural world.
From aerospace and automotive to life sciences, oil and gas.
How air flows around an object, how pieces of metal might crumple under pressure, how temperature and electromagnetic fields might move around a system. Solving those things is what computational science and engineering can really help with.
Sensitech is providing wireless sensors that are very small, the size of a postage stamp, that can be put onto a blade and then give you real-time temperature or strain on that blade.
I'm a PhD student here at Liberty University. I'm working under Dr. Mark Horstemeyer to design helmets and other protective equipment to better protect the brain.
Exponent is a scientific and engineering consulting company.
Anything from consumer electronics to the oil and gas industry to medical devices.
So different clients come to us with maybe a cell phone or an augmented reality headset.
The thermal performance of wearable devices.
We're best known for doing failure analysis work.
We've seen an explosion of HPC architectures in the cloud.
In the old days, it was about buying a bunch of servers a couple of years in advance and hoping that you bought the right one and you bought enough. We are moving towards a future with a cloud-enabled high-performance computing that allows scientists and engineers to collaborate very quickly and instantaneously and have a continuous integrated model of the overall product they're trying to create together.
It gives you access to this scale that is not available to you before.
You have the opportunity to just start with the software and run whatever hardware you want for that one simulation.
You can take advantage of the new hardware right as it comes out. You don't have to consider the investment you've made bought on-prem and have to wait 3, 4, 5 years for that to be fully utilized.
We learned about how Rescale works, and we learned that we can basically get on-demand access to very, very large computing hardware. And that enabled us to really tackle jobs we really couldn't tackle previously.
We have to be able to do things in such a precise manner.
We use Rescale to run the simulations. And what Rescale provides us is not just an ordinary HPC computer.
Rescale was an excellent resource for us to go to when we didn't have any on-premises resources that enabled us to select exactly the type of hardware we need, specify exactly the number of cores per CPU.
That was a big game changer for us.
Rescale is a computational science and engineering platform. We automate the entire technology stack that scientists and engineers depend on, so they can focus on discovery.
Rescale was founded to help customers get the best of what's possible in the cloud, as well as make their transition to cloud computing go much more smoothly.
It's made for scientists and engineers so that we can pull together all the tools they need, from infrastructure to software to data analytics tools.
Software ready to go tuned and patched, right? So you have that security layer, but you also have that kind of frequent cadence and updates.
One of the big things that really stood out to me originally about Rescale was how streamlined and smooth the interface was.
The platform is easy to use. You can just upload your workload, and then you can choose the type of software that you plan on using.
It's just kind of a drag and drop situation. If I'm running a lot of calculations that are very similar to the previous calculations, then when I get into the Rescale environment, a lot of that previous information is saved, or I can clone an old job, and then I just step through the process very rapidly.
The user interface is really centered around what is the engineer or scientist trying to accomplish. They're trying to get a simulation completed. They're trying to upload their data, find out some answers, and move on to the next step of their project. They're not trying to maintain infrastructure. They're not trying to set up software. They're not trying to figure out how a queue works.
We were able to run over 100 different design iterations in about 2 days. And if I did it locally, it just wouldn't be feasible. So I think that was one of the moments when I realized the power of having the cloud.
I can submit 10 jobs in parallel and have them running all at once. And so for some of these larger calculations that may take several days to run, I can run 2 or 3 of them all at once. And so in a span of a few days, I have all of my results.
The speed up that we've seen once we utilize the Rescale resources is definitely 5 to 10x faster than what we could do before.
What Rescale allowed us to do is to say, let's go run that and come back 15 minutes later. So instead of saying, oh, we're going to come back the next morning, we say we're going to come back after getting some coffee. And that's a much more human timescale. That timescale, instead of working at the speed of computing, you're working at the speed of human thought.
We're in a unique role at Rescale because we have the opportunity to both help R&D while at the same time giving IT and HPC organizations visibility on everything that's happening within their organization, compliance so that they can make sure they're doing things right, and the security and control so they can direct policies on making sure their data is sitting where it needs to sit and that they're using the architectures that are consistent with policy.
As an administrator, I can control what hardware is available to our users. Within the interface, we can set up budget alerts, and so that we know what our spend is on a given project, and our users are getting alerts to their inbox telling them, you're at 75% of your allocated budget for this project.
We also provide a lot of performance intelligence so that people know that they're making the right trade-offs between time to solve and cost.
It actually saves us money with our software licensing.
The cloud providers provide the infrastructure, the simulation software providers provide the software and the licensing, and what Rescale does is we bring it all together in a highly automated way.
Because it's cloud-based, you can simply select your resources that you wish to use. It's optimal for that particular simulation, and it's just a matter of allocating the funds, and it spins up and it runs.
If you're a scientist or engineer, it's a very exciting time because you get the software you want in the cloud, get the architecture you want in the cloud, and if you have a good automation platform, you can get all of that really easily on demand.
Rescale really has been a game changer for us.
Having Rescale enables you to, as a researcher, investigate all the options.
What Rescale actually does for us is helps us to be able to expand on our ideas without any restriction.
Multi-cloud for Sensitech basically means that we can do anything.